So on Monday in class, we started 5. So basically we've got 5-1, 5-2. We started those in class and we'll do a quick review of those. We have 5-3 we're going to do today and 5-4 that we're going to do Monday, and that's going to be it for the year. So we're kind of getting to the home stretch, the finish line. And 5-4 is kind of like the big section. That's why we skipped the section back in chapter 4, because I'm going to show you the easier way. So that's why we're spending a whole day on it. It's kind of one of those fundamental of algebra kind of things. So what all of 5-1, 5-2, and 5-3 are kind of building up to just different things that you need, building blocks for algebra, not necessarily things that you'll do on your own. So let me just remind you of what we did. So in 5-1, if you remember, we talked about factoring and that type of thing, but really what we were looking at is trying to find the pairs of factors of a number. And this is going to be huge for helping you in 5-4. So this is just, what are all the ways that we can make, we had 64 up there, but let's try a different number. What are all the ways that we can make, what are all the pairs of factors for the number 36? If this will let me write today. It wants to like not let me write up here. Come on, you can do it. It's glitchy. All right, fine. I will use paint. Okay, so in 5-1, what we talked about is pairs of factors. So if we have the number 36, and I asked you to find all the pairs of factors, what that means is 36 could be made with 1 times 36, 2 times 18, right? 3 times 12. Does 4 go into 36? Yeah, 4 times 9. And how I find these pairs of factors, just to kind of explain my thought process, is I start with the number 1. And 1 always divides it, right? And then I say, okay, does 2 divide into the number? Does 3? Does 4? And then I'm going to check 5. Does 5 divide into 36? And it doesn't, right? And then I go to 6. Does 6 go into 36? Yeah, 6 times 6 is 36. All right. And then I can keep going, but see, once I get to 6 times 6, I know that I've reached all the pairs of factors. Because if I go to 7, I know 7 won't do it. 8 won't go into 36. But then my next number is going to be, running out of space, my next number is going to be 9, right? And 9 is 9 times 4. So we're getting to the point where we're doubling our pairs that we've already had. So we don't have to repeat them, because 4 times 9 is the same as 9 times 4. So all of my pairs of factors are 1, 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Okay, and you're going to see on Monday why those are important to know. So that is 5.1. Give me just one second. Sophia is emailing me. Like, are you going to come online? All right, so does that make sense? 5-1, pretty easy section, right? All right, okay. So 5-2 then is, five two is a little bit different than that. So this is where we were talking about when we have exponents in the numerator and denominator and being able to divide by exponents. So let me see here. We did a couple examples from your book for this, right? So just quick review. If I have, won't you let me write on here? If I Just doesn't want to let me write on the screen today. Usually I can use a whiteboard. If I have, for example, this is 25 a cubed b squared divided by 5a b cubed c. And I asked you to simplify that. Could we do it? Well, after we did 5-2, hopefully we can do it once you start practicing that, right? So what you want to do is when you have this is a fraction, right? But everything in the top is multiplied together and everything in the bottom is multiplied together. So we are allowed to kind of break some things apart in our multiplication. So what I mean by that is this is the same as 25 over 5 times a to the third over a times b squared over b cubed times 1 over c. And you're allowed to break this up. These two are equal to each other because this is all multiplication and this is all multiplication in their division. If you threw in a plus in between these two, then can't do this anymore. So this only works when it's all multiplication. Okay, so we've got 25 divided by 5. That's just 5, right? We've got a cubed divided by a. So we'll just leave all of our fractions. So a cubed divided by a is just going to simplify as a squared, okay, over 1. Because you're taking, if you think about this, this is a times a times a divided by a, okay? And then we cross out those two a's and we're left over with a squared in the numerator, okay? What about b squared over b to the third? Does anybody know what that would be? So this would be b squared of b to the third would be b times b over b times b times b. So this b and this b is going to cancel out this one, and you're left with 1b in the denominator. So 1 over b. And then 1 over c, nothing's happening with that guy. So now we pull it all back together. We multiply across the top. We have 5a squared over b times c. So that's how we would simplify this equation in 5-2. Does that seem familiar? When I was doing it, did it make sense? Hey, Sophia. Okay. It's probably one of those things you got to practice, but you can get. Awesome. You got it before I wrote it. Nice. Okay, so now let's do 5-3, and then I'll let you guys get on your way. So 5-3 is a little bit different, and that what happens when we throw, so 5-2, I said, oh, it's nice and easy because everything's multiplication, right? 5-3 mixes it up because all of the sudden we have addition or subtraction inside of our problem. Okay, so there's a bunch of words here, and I'm kind of teaching this differently than my notes, so I really should update my notes. Oh, I think we did do this one, didn't we? Maybe really quickly we did this one in class. So let's do, let me grab one from your book in 5-3. So the difference between 5-2 and 5-3, in 5-2 it was just all multiplication, right? And in 5-3, we're going to have addition and subtraction in there. So what I mean by that is, okay, so this is number 15 from your book. I'm on page 196. We're almost to page 200. PQ cubed minus PQ cubed q divided by pq. And the idea is to simplify this expression. Okay, so before we do that, I want to just give you a super duper quick example that I think I did in class on Monday too, but I just want to tell you a really, really easy example, okay? So if I have, yeah, Jake, this one is a homework one, number 15. So if I have, sorry, I'm just trying to think of a good problem that has nice, easy numbers. Okay, if I have 8 plus 12 divided by 4, okay, there's 2 ways I can solve this. I could do 8 plus 12, which is 20, divided by 4, and I would get 5, okay? I can also, when I have addition in the top in the numerator and division on the bottom, I can also break this apart. So I can also write this as 8 divided by 4 plus 12 divided by 4. Okay, now you wouldn't do this for this particular problem, but we're going to use this second method for this. So 8 divided by 4 is 2. 12 divided by 4 is 3, and 2 plus 3 is 5. So I just wanted to show you that this method works. Obviously, you're going to probably do the first method if you have whole numbers, but the second method of dividing up, like when you have an addition problem at the top, you can divide the denominator by each item in the numerator, and it's the same. Okay, so let's see if you can transfer that over to here. So that means for this particular equation in 15, I can rewrite this as pq cubed divided by pq minus p cubed q, it's like a tongue twister, divided by pq. So these 2 equations or 2 expressions are the same. All right, and it's the same reason that they're the same over here, because you can, when you have something in the numerator that's addition, as long as you divide everything in the numerator by the denominator, you're allowed to do that. So are you guys okay with this, what I just did? How I changed my original equation to an equation where PQ is dividing each term. Okay, so now comes the work of just simplifying. So now it's like, this is 5.3, right? Now all of a sudden you switch back to 5.2, right? This is simplifying each of these. So what you're going to do is you're going to simplify this, and then you're going to simplify this. They're like their own little problems within the problem, right? If I have PQ cubed over PQ, the P's cancel each other out, right? And then this is P to the third over, or excuse me, Q to the third over Q to the first. So that's just going to leave me with Q squared, right? Because it's on the top, it's Q times Q times Q. And the bottom, it's Q. That looks like 9s. I cross out one, and I'm left with Q squared. Okay. And then my second equation, I have P cubed Q over PQ. The Q's cancel each other out, right? P cubed divided by P equals P squared. So another way of writing this original equation would be Q squared minus P squared. They actually mean the same thing. All right. So what do you think about that? Not too bad. Okay. Anyone want to see another example like that? Yep, see another one? Okay. Let's do number 11. And you guys try it too. All right, so I'm going to start writing it down. You guys try number 11, see if you come up with the same thing. Because this one looks crazy, right? And this is on page, it's on 196. All right, so I'm going to give you guys a minute or two to try it. All right, so I'm going to start doing it on the screen, but you guys keep working. Does anybody have close yet, you think? You think you might have it? All right. Yep, you do need to divide, Sophia. That's right. Okay, so you divided, did you divide every, so these are, in algebra, these are called terms, just so you know. Okay, so these are called terms. So what you want to do is you want to divide every term by 11y. Okay, awesome. So all three of you think you got it. So I'm going to go ahead and do it, and you guys tell me if you got it or not. I'll trust you to be honest with me. Okay, so 33 divided by 11, and 33 divided by is 3, right? Yep. And then y to the fourth divided by y is y to the third. Okay. 11 divided by 11 is just 1. And y to the third divided by y is y squared. Minus. And then we've got 44 divided by 11, which is 4. And y squared divided by y is just y. Okay, so now can I do anything to this equation? Nope, that's right. You can't do anything because we've got a y cubed, a y squared, and a y, so they're not like terms. So this is going to be the simplest that we can get. So if you got 3y cubed plus y squared minus 4y, then you got it. Awesome. So, yay, Olivia got it. Jake, did you get it? Yay, awesome. That's awesome. All right, so we are actually not quite done yet because there's kind of a reverse of this. Okay. But wait, there's more, right? Okay, so what do I mean by the kind of a reverse of this? Well, we're going to start doing something on Monday, and this is kind of the precursor to this. So what we were doing is we were dividing out a term from that equate. We were dividing out a term. Let me start back. What we just did is we divided out from expression, right? So let me take a step back. If I have 4x minus 8, okay? And I asked you to factor that. This is going to be the kind of the next thing we're going to do. This is the homework. That's not what I was trying to do. It thinks I'm swiping my screen when I write it. Line. Factor. Okay, so we're going to be doing something called factoring in the next section. So this is your problems 31 through 30. I don't know what I have assigned. 31 through 37 or 39, something like that. So this is the second part. So if I have 4x minus 8 and I asked you to factor that, what you want to do is right now you can't combine 4x or 8, right? They're different terms. But they do have something in common. Do you know what 4x and 8 have in common? They both share a factor of 4, right? So if I wanted to, I could divide a 4 out of each of these. And there's kind of two ways that you could do this. So the reason that we're doing division is so you could see the 4. I could divide a 4 out of this, or I could take a 4 out of both terms. So what I mean by factoring is what you're going to do is I'm going to say 4x and 8 both share 4. So I'm going to pull a 4 out of each of these. Okay? Just bear with me. I'll explain this again. So if I pull a 4 out of 4 times x, what do I have left over? I have x left over. Okay? Minus, and if I pull a 4 out of 8, I have 2. Okay, so another way of writing 4x minus 8 is 4 times x minus 2. These two are equivalent expressions, and we would say that this would be the factored form of this. Okay, why this works is that it's my favorite property. I told you it's coming back, right? If I distribute this 4, right, I get 4 times x minus 4 times 2, which is 4x minus 8. So this is what we're going to, our ultimate goal of what we're trying to do. But let me kind of re-explain why that had to do with the dividing. So what you're going to try to do is you're going to try to figure out, okay, I have 4x minus 8. I think I have a 4 in common with all of those. So if you think about it this way, it would be 4x divided by 4 minus 8 divided by 4. 4x divided by 4 is x, and 8 divided by 4 is negative 2. Okay, so here's that same term that we had up here, and what we pulled out was a 4. So that gets to go here. I'm trying to kind of explain how they all go together. So let me do a couple more examples so you can kind of see what I'm talking about. Okay. So this is kind of our introduction to factoring. So if I have, let's see, what do I want to do? If I have 16a minus 18b plus 12. Okay, and I asked you to factor it. What you want to do is you want to go and you want to say, what do 16a, 18b, and 12 have in common? 16a, 18b, and 12. What do they all have in common? So this is, we kind of skipped over this section formally, but I think that you guys can figure it out. So does anyone know what do they have in common? They don't have an A or a B in common, right? They have 2 in common. Yep. Is there any number bigger than 2 that they all have in common? 3 doesn't work, right? Because 3 doesn't go into 16. 4 doesn't work because 4 doesn't go into 18. 5 doesn't work. 6 doesn't work because 6 doesn't go into 16. So 2 is the biggest number that they have in common. Okay, so what we're going to do is we're going to pull a 2 out of all of these. So we're going to, and you can pull the 2 either way. Okay, and we're going to pull a 2 out. So if I pull 2 out of 16a, what do I have left over? It's kind of like a puzzle. Yeah, I think you said 8a, right, Sophia? You got 8a left over, right? Minus, and I pull a 2 out of 18b. So what do I have left? 9b, And I pull a 2 out of 12 and I have 6. Awesome. That's exactly how you would factor it. So this would be the factored form of 16a minus 18b plus 12. Olivia and Jake, what do you guys think? Kinda ish. That's a little bit down the line. We'll get to that by the end of chapter 5. What it eventually will help you do is solve these equations. But right now, pretty much, so we're going to start it today. Monday, we're going to do a ton of factoring, and pretty much the whole rest of chapter 5 after we, through break and get back from break, we're going to be factoring. I know, getting close, right? All right, so let me do another one that's a little bit different. Okay, and let's see if we can do it. So we've got 9s cubed plus 15s squared. Okay, so what you want to think of is, what do 9s cubed and 15s squared have in common? So first we look at the numbers, 9s cubed and 15s squared. First we look at 9 and 15. They both share the number 3. Okay, now here's the tricky one. S squared and s cubed, what do they share? You could take an s squared out of both of those. So if you're not comfortable just doing it visually like this, one option is you can actually like divide like this and figure out what the factor is. Okay, I think it actually kind of adds a little confusion, but it's okay if you want to do it that way. I like to just kind of think of it as a math puzzle. Okay, so I'm going to pull out 3s squared. So if I pull 3s squared out of 9s cubed, I'm left over with 3, and then s squared times what gives me s cubed? 3s. Okay. And then if I pull 3s squared out of 15s squared, I'm just left over with 5. And then if you ever are like, I'm not sure that I did that right, you can also redistribute and check, right? 3s squared times 3s is 9s cubed. 3s squared times 5 is 15s squared. We're like playing magic on our expressions and changing them around, right? So let's do one more that has these variables in it. And I'm going to have you, again, I'm going to have you guys try it and then I'll do it on the screen. Okay, it'll be a homework problem. So let's do number 35 on page 197. So we've got 6p squared times q minus 9pq. Okay, so you guys try that out and then I'll do it on the screen. And let me know when you think you got it. You guys are fast. All right, you guys are speedy. I'm impressed. Okay, so what do they have in common? Who wants to tell me what they think they have in common? A 3, right? Do they have any variables in common? Olivia, yeah. Yeah, a 3 and a P and a Q. Awesome. So if I pull a 3, a P, and a Q out, I am left over with, if I pull a 3, a P, and a Q out of this, I'm left over with 2 and 1 P, right? And the second one, if I pull a 3 PQ out of that, I'm left over with just 3. So that would be it. You guys got it? Yay! Awesome. If this is this is what we're going to be doing a lot of, so I definitely want to make sure you guys got it. How'd it go, Jake? Awesome. All right, well, that is all I have for you guys to do today. I know you guys are working on your homework. Does anyone have any? Jake, just send your homework in when you get it done sometime today. I won't be grading it until tomorrow. If you have anything that's tricky, please let me know and I will I can go over any problems that you have. Yeah. That would be like, what am I doing? That's it, unless you have any questions from your homework. You guys did great. We're really, really close. We've got, yeah, we don't have much left, just one more section, so. $27 and 4.4? Sure. $27 and 4.4. Did you have to do 27 and 4.4? Yeah. No, 4.4. I thought you said 4.7. Hold on. I'm like looking at 4.7. I'm like, I don't think we had to do that one. 27 and 4.4. You did have to do that one. Okay. Sure. I can do that one. Do you want me to do 3? Okay. Okay, so let's do 27 first. So we've got 1/2 p squared q cubed times 2p q squared to the 4th power. Okay, so where do we start? Do you know? Yeah, we got to get rid of those parentheses first, right? Huh? Yeah, we got to get rid of these parentheses first, right? So what we're going to do is we're going to distribute our cubed thing, okay? So we've got 1/2 cubed. We're just going to leave it like that, okay? And then we have p squared cubed. Do you know what that would be? P to the, what was that? P, yeah, p to the 6th, right? Because we're going to multiply 2 times 3. And we've got q to the 3rd, right? And then we have to do the same thing with this one. We have to distribute our 4. So it's going to be 2 to the 4th, p to the 4th, and q to the what? 2 times 4 is? Uh-huh. Yep. All right, so now we need to group these guys together. So we've got 1/2 cubed times 2 to the 4th. Okay, that's one whole thing. Then we've got p to the 6th times p to the 4th. And then we've got q to the 3rd times q to the 8th. So let's do p to the 6th times p to the 4th. When you're multiplying, we just add them together. So we're going to get p to the, yep, and q to the 8 plus 3. Yep. And then this one is actually a little bit tricky. So I would actually use a calculator for that. But what you're actually going to find out is this is actually just going to turn out to be 2. So if you put it in your calculator, if you just have a simple calculator, let me see. Calculator. So what I would do, that's what I was going to show you. What I would do for this fraction, Sophia, is I would do it instead of as 1/2, I would do it as 0.5 times 0.5 times 0.5, right? So that's going to be 1.125. And then 2 to the 4th is, see, this calculator doesn't even have all that fancy. So 2 times 2 times 2 times 2. So 16. So 16 times 0.125 is 2. All right. So what was the other one, number 3? All right, so x, y squared, x squared, y squared, and x, y squared. All right, so let's do these guys. So x is 3, y is 2, and the first one is x, y squared, right? Yep, just make sure I wrote it down right. Okay, so what you want to do is you want to plug it in. So x is 3, and y is 2, and 2 is squared. So once you plug it in, the first thing you always want to do is order of operations. You want to do the exponent first, right? So 2 squared is 2 times 2. That's 4 times 3. 3 times 4 is 12. So that's A. Okay. So B is x squared, y squared. Okay. So we want to plug it in. So it's 3 squared, 2 squared. So again, we've got to do our exponents first. So 3 squared is 3 times 3, which is 9. And yeah, and then 2 squared is 4, and 9 times 4 is 36. Okay. It is. You're right. Yep. You're good at figuring those out. Awesome. Any other questions you want me to go over? Okay. Sure. So this is in 4.5, right? Four point five. Number 17. Multiply. Fractions, huh? They just don't go away. I know a lot of people get to algebra and they're like, I'm finally done with fractions. No, they're still here. Do you know Mackenzie Allison? Yeah. I just didn't know if she was in any of your classes, Mackenzie. She was in my algebra class last year, and she was like, every time there's a fraction problem, she's like, can I just make it a decimal? Oh, okay. Yeah. She was like, I just don't like fractions. Okay, so what you want to do you know what you want to do to simplify this? What's that? It's not you. I just can't. I'm having hard problems hearing. You're just really light. Yep. Well, to get rid of the parentheses, you're going to use my favorite property. You're going to distribute it. Yeah, so it's going to be 1/3 x squared times 6x squared minus 1/3 x squared times 9xy minus 1/3 x squared times 3y squared. Okay, so actually the fractions here aren't too bad. So 1/3 times 6, we're going to start simplifying this guy, right? 1/3 times 6 is actually just 2. Okay, and then what's x squared times x squared? X to the 4th. Yep. Okay, so now we have the second one. We've got 1/3 times 9, which would be 3. And then what's, x squared times x is, x to the 3rd. And then don't forget y. So y gets to come in there too, but nothing happens to him, right? Okay, last one is 1/3 times 3, which is just 1. And then what's x squared times y squared? It's just x squared. Yeah. Because we can't do anything to it, right? $25. 25 looks crazy, but it's actually going to be kind of fun. Well, for a math teacher. Okay, 25 has a bunch of brackets and it looks super intimidating, but actually when you simplify it, it actually all kind of cancels each other out, so it's fun. Okay. That's why it's fun for a math teacher. Okay, so what you're going to do is, this is like my favorite problem because it's like distribute, 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 right? We need to get rid of all of these parentheses. So the first parenthesis that's going to be easy to kind of simplify is this one, right? So what do we need to do to, yeah, that one's easy. So what do we have to do? Yeah. Yep. So we are going to get 5 times a, which is, 5a. Minus, yep, you got it. Yep, 5a squared, right? Okay, so that one's easy. We got that taken care of. Now we got all this going on over here. So what you want to do is you want to work from the inside out. So what I mean by that is we want to deal with this first. So how are you going to deal with Yep. But actually, since it's a negative, we want to distribute a -3 because that's actually going to make our life easier. Okay. So we leave everything else alone. Okay. So what's -3 times 1? -3, right? And -3 times -a is, it's actually, positive 3a. Okay. So now, can we add anything up inside these brackets? 2a plus 3a, right, is 5a minus 3. And this all stays the same over here, right? Dot, dot, dot. Keep going. Now, how do I simplify this? Distribute the A, right? So A times 5A is, yep, 5A squared, right? What about A times 3? Uh-huh. And now we can bring down what's over here, plus 5A minus 5A squared. So 5A squared minus 5A squared, those cancel each other out, right? Yeah, it's just 2A. That's it. The whole big crazy looking thing. Yeah. Yeah, sure. All right, you too. I'll see you on Monday. All right, bye. Yeah, if that works. Yeah, or scan it, whatever. Yep. All right, thanks. Bye.